Good morning, guys. Hopefully you guys are doing okay at home. I know I'm kind of ready to go back to work and I wish I was with you guys. But hopefully this ends soon. Just make sure you're staying home as much as you can and trying to keep yourself busy. Other than just watching Netflix, that way you're still you're still using your brain other than just watching shows. I'm definitely ready to get out of here as soon as we're all clear to go. But anyways, yeah, I just wanted to say that I'm thinking about you guys and I'm hoping you're all doing well. So for this video, what I wanted to do was just go over again everything that we've covered so far. I know last lesson I had given you this exit ticket before you guys left, and it was just more for you to think about. So the question said, explain the difference between a tangent segment and a secant segment. So if you remember, obviously, for example, actually I'm a very visual person, so I'm gonna go ahead and take the graphic organizer now. So if we go to the tangent, we see that this would be an example of a tangent on the circle, whereas a secant, we see that it goes outside of the circle, right? Or it intersects the circle at the 2 points. So here it touches it at this point and at that point. So I just wanted you guys to think about that, and if you were able to answer that in your head, then awesome, you're definitely understanding the material so far. And then if it was a struggle for you, then this was just a way to assess yourself and to use the resources that you have. So for today, again, we're gonna go ahead and go over this graphic organizer in particular only because I find it very useful and I really love how everything is set up. I haven't seen anything like this online, so I just really hope that this is helping you understand everything. Okay, so again, we're gonna go over all of these vocabulary words, and these are all the theorems that we've covered so far. In your textbook, however, they're just labeled a little bit differently. So if I show you really quickly in your textbook, everything that we're going to go ahead and cover is here. Again, for example, here the theorem is 10.4, congruent central angles theorem. If we move on to, let's see which one. All the theorems that were pretty much on the graphic organizer, they're mostly coming after 10.4 because you will notice that if you go to these sections, all the major theorems are stated on these sections. So it can definitely seem like a lot at first. So we're going to just go ahead and do that, okay? So again, the central angle here is, we have the type of the angle, and then we have the picture with the formula. So here we have a central angle. In this case, the central angle is this one, right? And whose sides are the 2 radii. And then this angle is directly connected to this arc here. If we know this angle, then we know that this arc. And if we know this arc, then we know the central angle. And then here is the formula given to us in the most easiest form: angle equals arc. Then the second one that we learned was the inscribed angle. And this one is when it's when the angle has sides who are, unlike this one, they are not the radius, they're just any chord. And so here we know it's also connected, the angle and the arc is connected, but instead the angle is equal to 1/2 of the measure of the arc. Okay, and these are just some different ways that you could see this type of inscribed angle. You could see it where you see the arc right opposite of this, or you can see it where the tangent is where we have a tangent line, and then we see that this angle here, this is the inscribed angle, but again, we're still using the same formula. The angle here is equal to 1/2 of this arc. So if this is 150, then in order to get this arc, it's equal to 1/2 of this, so it would be 300. The arc measure would be 300 in this case. Okay. And then here, this angle, half of the arc, would be 60, so this inscribed angle here would be 60 degrees. Then we learned about the vertex that was inside. So here we have, think of it as the vertical angles, right? Whenever you see this X here, not this larger one, not this little angle here, we see that in order to find any of these angles here, we would add up the opposite arcs and then divide that by 2. So in here it says angle equals 1/2 arc plus the arc. Then we learned about when the vertex was outside. So we have this secant, these two secant lines, and they are on the outside. In order for us to figure out this angle here, we're going to take the difference of these two and divide by 2. And then this is the formula that they gave you. Angle equals 1/2 arc minus the other arc. So then the second part of this graphic organizer, we learned about the two tangents. And then this kind of looks like a snow cone if you look at it this way. And you just, every time you see this, you see that this side is congruent to that side. Okay? And so that's the formula given. Tangent equals tangent. Then we moved on to the tangent and radius or diameter, and this is actually one of the very first ones that we covered. So that we learned that this angle here makes a right angle, and the formula here, it's not a formula, but it's just a note for us to think about, is that the tangent and the radius or the diameter are perpendicular. Which would be very useful, which can be very useful to some problems when this is all we're given. We would have to know this fact, know that how the tangent and the radius or the diameter are connected. Okay, so then we learned about the two secants, and this is this can be, when you're looking at it as a whole, just this portion itself, it might seem very easy. But I will tell you that sometimes this can be very confusing, because then you start doing only this part individually and you're not doing that, okay? We're not going to confuse it with something else here. So here we're doing the whole thing. So it's the whole, again, we're adding the sides. So in this case, it would be 10 times the outside, which is 3, equals the whole thing. It's x plus 2 times the outside of the circle, which is 2 in this case. And then you would solve for x accordingly. Okay, so just be very mindful of this one in particular. I feel like this one would be the one that would confuse most of you guys. Okay, then we have the secant and tangent. In this case, we have, this is what I was talking about, right? Earlier with the exit ticket. We see a secant is the whole thing here, right? That intersects the circle at 2 points. Whereas the tangent, of course, we know that it only touches the circle at 1 point. And in this case, our formula is the whole thing here. So it's this times itself equals to the whole thing, which is 10, times the outside, which is 4. This one I think is going to be another one that might be a little confusing. I'm not sure, depending on how you feel about it. So definitely, if you're not 100% sure, go back to these and just keep revisiting these two theorems in particular. And then finally, this is actually one of my favorite ones. It's the two chords theorem. And you're just doing whatever whatever you see when you have these two equal parts, right? Then you are, or sorry, not two equal parts, but whenever you have this piece, all of these pieces, you're gonna go ahead and multiply them all together. So we have in this chord, piece times the other piece equals to this piece times that other piece. Okay, so that's all. That's so far. That's pretty much sums up everything we've covered. And then we're gonna actually go ahead and start something a little bit different after this. So it's still involving circles, but definitely I would say make sure your understanding of this is okay. If not, just make sure that please make sure that you're reviewing it if you need to. There's no shame in having to rewatch these videos, or looking at your textbook. Whatever helps you, please feel free to do it. Okay, so that's pretty much it for this review video. Bye guys.